Ferrofluid. This dark liquid was invented by NASA early in the space program for use in outer space. There's no gravity in space to hold a liquid at the bottom of its container, so it is difficult to control liquids. In outer space, they can go anywhere inside a container, like on the bottom, sides, top, or even right in the center of, say, a large fuel tank. It would be nice to control fluids with something else than gravity. Well, NASA decided to use solid fuel instead, and now I've got ferrofluid sitting here on my table. It doesn't look fancy or alien to me. Wait, what? In this video, we'll encounter strong magnetic fields and messy stuff. Ferrofluid is attracted by a magnet, so much that it doesn't care about gravity and lifts up in these nice spikes following the magnetic field lines. I have placed an extremely powerful 6x2-inch neodymium magnet under the table to control the ferrofluid. Not just for the visuals, but also since I don't want to drop this by accident directly onto the magnet. The cleanup would be... I would rather clean up after an exploded whale. But for your viewing experience, I'll get it as close to the uncovered magnet as I dare. If I go too close, the magnet will lift up or pull the glass tray out of my hands, smashing the glass and, well, do not try this yourself. At this point, I was struggling to keep the tray level and away from the magnet. Time to chicken out. This magnet will always win a fight. What I do there is something that countless of you asked for on my previous video. Touch the spikes. This is not recommended since ferrofluid is a skin irritant. I will wash my finger right after the recording to avoid a skin rash. As you can tell, the spikes are very soft and stain a lot. The fluid has already run under and around my nail. Moreover, ferrofluid is a serious eye irritant, so wear safety goggles and don't scratch your eye with a stained finger. Luckily, it isn't toxic, so I just need to clean my finger. Let's go a little deeper with gloves on. While on the subject of safety, let me mention that the liquid itself will destroy your lungs, so don't pour it into them. With common sense and basic safety gear, you can handle ferrofluid without any health problems. Just expect a lot of messy cleanup afterwards. After cleaning the glove, I noticed it had gained a metallic sheen from the ferrofluid. Ferrofluid contains nanoparticles of magnetite and they may have settled in tiny pores in the glove. I wonder what it did to my skin then. Maybe I'll turn into a pigeon, being able to detect the Earth's magnetic field. Nah, but use gloves when handling ferrofluid unless you want to wake up every morning facing north. On a more serious note, have you noticed a special detail on the spikes? Some of them have a thorn at the end. I have never seen this before. After tweaking the distance between the magnet and the ferrofluid, I got this result. My guess is that this is a sign of how powerful this monster magnet really is. Its magnetic field is so strong that the magnetite in the fluid is stacked high enough to break through the surface tension of the carrier fluid, petroleum in this case. This looks so cool. The monster magnet never disappoints me. Let's take a closer look at how these spikes are formed. Here I sprinkle iron filings near a magnet. As you can tell, the filings get magnetized and line up following the magnetic field lines. The magnetite particles in the ferrofluid react in the same way. But the iron filings here are like a powder and form random spikes with different thicknesses, heights and spacing in between. If we suspend the magnetic particles in a liquid instead of air, the surface tension of the liquid helps shape the spikes in a much more ordered manner. The surface tension wants to contract the liquid, making the surface area to volume ratio as small as possible. It can be shown by pouring oil into water. The surface tension forms the oil into spheres underwater, where only water surrounds the oil. Spheres have the lowest surface area to volume ratio of any shape. That's why soap bubbles are spherical. Rings of oil form on the surface where the oil is surrounded by both water and air. The molecules of the oil just want to clump together as tightly as possible due to the surface tension. The same thing happens in ferrofluid, where the surface tension acts like an elastic film between the air and ferrofluid and smoothes the surface out. Here I have stretched an elastic latex glove so it's under tension. This simulates the surface tension. Now imagine that this pin is the magnetite particles forming a spike like the iron filings inside the liquid. The surface turns into this nicely smooth spike like we see with the ferrofluid. Actually, this setup may be more precise since the trapped air inside the bowl represents the fixed volume of the ferrofluid. As I form a spike like the magnetite rising inside the fluid, the volume of fluid needed for the spike must come from somewhere else, forming a valley around the spike. Pretty neat. It is also worth noting that the magnetite particles cannot settle at the bottom of the liquid. They are so tiny that they will stay suspended in the liquid just by the random movements of the molecules in the warm fluid stirring it up. The particles cannot clump together either since they are covered in a surfactant, preventing them from sticking to each other. So, despite the solid particles in it, ferrofluid always acts as a liquid, even near a magnet, but the magnetite particles are attracted to and align with the magnetic field lines, making it look like solid spikes. That's why the spikes are very soft to the touch. They can't even hold a Lego piece at their tips. In fact, the spikes are so soft and liquid that you can move them by just blowing on them. Alright, hope you enjoyed these small experiments. I'm not gonna bore you with the tedious cleanup. But before I pack the monster magnet away again, let me just show the magnetic putty on it as well. I showed this with smaller magnets in a previous video that Supermagnet sponsored. This amount of putty is too small to be really spectacular near this large a magnet, but still impressive how organic it looks when it moves. Okay, I hope you liked this video enough to click the like button. Thanks for watching, and keep watching until the end if you have commented about your reason for subscribing. You may be in the 5th frame. Bye for now.